So moving on to our next learning objective, this was probably like the most important thing for this entire unit, is that you understand function notation. All right, so function notation is this thing that's not going to go away for the rest of your math career. All right, it's a very helpful tool for us to talk about functions and their inputs and outputs without having to explain a lot. All right, so if we're talking about a function, we need to talk about what our input is and our output is. So we might simply say something like we put in 3 into our function, so the number 3, and we get out the number 5. All right, so that's a sentence. Mathematicians in general are pretty lazy and don't want to write out a whole sentence for something that they're going to have to do a lot, so we don't want to have to say that whole thing. We put in 3, we get out 5. One way you could do this is just use the little arrow. So I actually did this in the function video. 3 goes to 5, so when I put in 3, I get out 5. And that kind of makes sense, but it's not going to work too well once we start doing things. So once I want to take this and like add stuff to it or multiply it, it doesn't really quite work anymore when we're doing all algebra stuff mixed with our function. So we do want a kind of way to shorten this notation and make it easier to look at. And the way we're going to do it is called function notation. All right, so this is what it looks like. It looks pretty simple right now. F of x equals y. All right, so you say this is f of x, that's the left-hand side, equals y. All right, so there's 3 different parts. All right, f for function, but f is the name of our function. All right, so we give our functions a name. So if we have multiple functions we're dealing with at the same time, we can call one f. Generally, we'll call the next one g, and then h, because that's kind of the order of the alphabet. All right, but we give our function a name. All right, x we know is our input. All right, so this represents me taking x and putting it into my function named f. And then we know we get something out of that. So once I do that, I get my y value, which we know is our output. Right. So the function name in the parentheses is the input, and that's equal to the output. So this is the shorthand way of doing what that sentence says. I take x, I plug it into f, and then I get out y. So if we think about that one from the previous slide, I put in 3, I get out 5. If my function was named f, that would look like this. F of 3 equals 5. All right, so I'm putting 3 into my function, and I'm getting out 5. All right, so now we're going to do this with a few different things. We're going to start off with tables and graphs, and then in another video we'll kind of go to expressions. All right, so here we want to evaluate f of 2. So remember that this 2 here represents my input, and my input is my x values. So I go to when my input is 2, and the output that's associated with 2 is -4. So that's going to tell me that f of 2 equals -4. When I put in 2 into my function, I'm going to get out -4. And all of these are going to be exactly the same. So f of 6, I'm looking for when my input is 6, and that says my output should be 2. So f of 6 is equal to 2. And then finally, f of 11. Again, now my input is 11. That's what I'm putting into my function, so I want my x value to be 11. And the output that goes with it is 3. So now the f of 11 is 3. All right, so I'm dealing with a table. You just have to remember the thing in parentheses is your x value. The thing you want to get out is your y value. And this next example kind of forces us to go in the other way. So we have the exact same table as before, and now we want to solve these equations. All right, but we're solving when does f of x equal 12? Well, now the 12 is on the other side of the equal sign, and remember, if it's equal to, that's our output, y. So it's telling us that our output should be 12. How we find where that happens? The x value, the input that made that happen, is above it. That's 9. So if f of x equals 12, then x had to be 9. So that's the solution for that. All right, just like you were solving equations in previous learning objectives, x equals 9. All right, next, when does f of x equal 2? Well, f of x equals 2 here, and if I keep going along, it actually equals there as well. And we saw this when we were talking about functions. You can't have the same y value multiple times. You just can't have the same x value. Right? But we can see there's 2 different columns that matter. So when we solve this equation, we get x equals 1 and x equals 6. All right, there's two different x values that can get me to that y value of 2. All right, and lastly, f of x equals 0. I find 0, there's only one of them, so I know that my answer is going to be x equals 7. All right. So when you know the thing in the parentheses, you start with x. When you know the thing it's equal to, you start with y. All right, so go ahead and try this video yourself. All right, slightly different function. All right, but same thing. One you're going to evaluate and one you're going to solve. And these are the solutions I got. So f of 5, again, in the parentheses, that's my x value. So I look at that red column that I highlighted. When my x value is 5, my y value is -4. So f of 5 equals -4. I have to solve f of x equals -2. You're looking for all the x value that make your y value -2. Well, that happens in two different places when x is 3 and x is 11. All right, so just knowing the difference between when you're evaluating, you're going to be equal to that one y value. When you're solving, you're looking for all the x's that could make that true. All right, so the last thing we're going to do in this video is look at graphs. It's going to be the same thing, all right, except for just remember a graph is kind of a pictorial representation of a table. All right, we keep our function notation x comma y in mind, and remember that x is the first coordinate going left and right, y is the second coordinate going up and down. All right, so when we put those together, we should be able to do these function notation things in our graphs as well. All right, so G is this graph. Again, like I said, you can give your graph or your function any name. So this time I'm going to give the name G. All right, so all that really changes is now there's a G in front here. All right, it just means I'm plugging into G rather than some other function F. So if I'm trying to find G of -1, again, remember that means my x value is -1, which is here. So my x value is -1. I need to figure out what y value goes with it. So similar to when we were doing the vertical line test, I can think about all the places that x is -1 is this vertical line. And the place that corresponds to on my graph is this dot there. All right, and that dot is the dot -1, 3. And this tells me, again, that's x comma y, but x is the input, y is the output. So that tells me when I put in -1 into my graph, I get out 3. So that tells me my function notation, g of -1, when I put in -1 in my function, I get out 3. Right. So when you're doing these with the graph, this is telling you what the first coordinate is. My first coordinate has to be that x value, and I figure out what the second coordinate, the y value, is. All right, so the next one, g of 1. All right, I'm going to go to 1 on my graph. That's here. And I see where it hits my graph, and that is down here. That's at 1, -3. So g of 1 is going to be -3. And again, the reason for that is because the point 1, -3 is on my graph. So 1, -3 means I put in 1 into my function, I get out -3. All right, and the last one, g of 2, I go to 2 on my graph. Again, because it's a function, there should only be one place where that line hits, and it's right there. And that's on the x-axis, that is 0. Right, that is the point 2, 0. So when I put in 2, I get out 0. All right, so this is how we do function notations with graphs. All right, the thing in the parentheses is your x value. Your answer is the y value that goes with it. All right, now again, we're just doing it in the opposite order. Now we're solving. So g of x equals 4. And remember, if it's equal to something, that's your y value. So now I go to -4 and I look at that horizontal line. Those are all the places where the y value is -4. And again, I get this one value there. And my answer is x equals, whatever that x value should be. It's kind of in the middle. The x value looks like it's about, let's just round it, about -2.5. All right, so that, if I put that x value into my function, I'm going to get out -4. All right, next is 0. All right, that means my y value is 0, which means I have not gone up or down at all, which actually just means I'm directly on my x-axis. and I'm actually going to get multiple points here. So just like with the tables we saw, you can get multiple answers when you're solving. I get all 3 of those points, and those points happen when x is -2, x is 0, and x is 2. All right, so remember, you can get multiple answers when you're solving, not when you're evaluating. So when I'm solving, if I put in any of those x values, -2, 0, or 2, I get out the y value 0. And one more, f of x equals 3. I go to 3, and I'm going to get these 2 different points here and here. And my answers are the x values that make that y value happen. So one of them is at -1, and the other, it's closer to 2 than 3, so maybe I'll say like 2.25. Again, it's not exact when it's not directly on the line, so it's a little bit of rounding for 2.25. All right, but that's just that x value there that corresponds to that point where my graph hits the y value 3. So if I put in -1 or 2.25 into my graph, I get out 3. All right, so once again, go ahead and try this on your own. New graph called f. All right, evaluate this expression and then solve that equation.